Hello. Hello, 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 hello. Hello. Hello, 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 hello. Hello. Hello, 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 hello. Hello. Today we want to discuss how to orchestrate LLM methods and AI agents. Uh, let's suppose these are the IoT devices. Let's suppose these are the IoT devices which detects the soil conditioning and health of the nature and health of the plants. These are manually deployed in the fields, and it is connected to a web server to like send raw parameters to like web server to analyze, to send that data to models for the analysis of the data. I suppose these data are being transferred using a main server, and this server is connected to a main web server which pipelines to a which stores the data, and it has a pipeline to like LLM models, and which is connected to this web server for the analysis of the data. LLM model will analyze this data as per the needed, as per the users, and the analysis data will be sent retrieved back to the web server for the transfer of data to the customer user. And let's suppose this is the customer, client, or users. So what is happening here? It is like data is being transformed. Let's suppose this data is being transferring from this IoT device's hardware to like a web server, and that web server is been connected to another web server which is be responsible for the pipeline to send data from coming from web server 1 to LLM models. So like for example, this is, let's consider this a web server 1 which is solely responsible to like take inputs from the IoT devices, and this is the web server 2 which is solely responsible for the like sending data to ML pipeline, and like retrieving data from ML pipeline, and like sending and receiving to the like data, and that received data to like send to database for the storage purposes, and and also and this also web server responsible to like serve that data to the users and client as per the need, as per the request. Let's consider this web server as a web server 2. uh, so the architecture of this will be in the solely based on the very simple methods. Like this is the first principle, like we have to thought about like integrating an ML model and like establishing a pipeline to like analysis of the data, and the main purpose and the main insightful analytical of this architecture will be like getting a very reliable data based on the hardware, like and we can predict we can predict the yielding of the crops by using the data and the analysis of the data. For example, this is not only based on the IoT devices, it will also receive the data coming from the weather APIs. Like we are building our highly crop predicting high yielding crop systems where the farmers will be like taking the they will be using the insights to like produce, to change and to make decision based on the crop, and like so this will provide a very useful insight for the farmers to like produce high yielding crops and like reduce the hmm, reduce the burden of the crops, like destruction of the crops and like failure of the crop. So it will prevent farmers to like prevent from the failure of the crop and low yielding, and it will give strength to farmers to like produce high yielding crops and predict the future crop failure and pesticides and insects and all the kind of things. And based on the data, they can make the decision and make reliable production of the crop. So this is not only this data is not only coming from the IoT devices. This data will also come from the weather API as well. This is the I will consider this is I will consider this as a, let's suppose let's erase this. Hello. Hmm. Hey, hold on a second. Where is this? So this is, let's suppose, yes, this is the architecture. Like this is not also based on the this will also receive the data coming from different weather APIs, like Bhuvan API, Crop API, ISRO API. Like they are the analysis. They have the data sets of the various analysis, and it also receives the data from coming from this API, and it will go back to the web server, and this web server will also the push to the data to the web server 2, and web server 2 will push the data to the ML model. Let's consider this as a LLM model. It will analyze this data. It has web server 2, and it will produce the data in the JSON format, and we will show the data in the mm, this it has also functionality of sending data to like uh, database. This is the dashboard. So this is a simple architecture of like how it's gonna look like if it's the first draft of the model. Like this is the first draft of the architecture. Like this model is getting the analysis data from the IoT devices and like web servers for the analysis and the for the future production of the crop. Like how it is gonna be how crop is gonna be gonna be yield in the and in the next coming 10 days and like 20 days. So it will give the insights. Like you have to make it will give the insight based on the data, and it will be very beneficial for the farmers to like predict the crop production and like to make decision based on the data. And it will also help to like produce high yielding crops and reduce the chances of failing of the crops due to the weather conditioning changing and like market needs and like pesticides. And it will also allow we can also use this to like pivot. We can also integrate different type of hardware and the machinery mechanism to like uh, provide LLM models and like models to like take decision based on the data they are producing. Like for example, we can connect like there are two three electric appliances that farmers are generally use for like irrigation purposes. I don't know the name of that, but I have seen two three types of machinery. Like they the machines which are being used for the irrigation purposes and like for the pesticides, they can be powered by AI to receive the commands coming from the LLM model and take the commands and like perform based on the command produced by the LLM model. For example, we can integrate that two three machinery. For example, this is the first JSON format to like see the data and to visualize the data which is coming from model. Now we are integrating the decision making and the working principle based on the command which is being produced by the LLM model. For example, this is also a pipeline. Let's suppose this is also coming from the web server. So, and this is the main server number 2, and all these are connected to a MCP server electric appliances. Let's suppose this is also a 2 number. This is also a 3 number. Yes. This is the hardware devices which are being connected to a web server. This is the general view like how orchestrating agent and the how everything will be look like based on the AI agents and all kind of thing. Also, we can integrate the AI agents to like purchase things for the purchase things and purchase pesticides and purchase products in the internet based on the generating and based on the data which is coming data based on the data which is being coming from the IoT IoT devices. For example, let's suppose in field there is a very less amount of potassium is being found, and plants is having very less amount of potassium, and the pesticides the farmers is using is not effective and not impactful to the plants and not giving sufficient amount of potassium the plant for the survival and for the growth. And the AI model is detecting that the potassium is low and earlier pesticide is not able to work and all kind of things. So based on the data, this is the second web server which is connected to the. Let's suppose this is the web server for the hardware. Web server for hardware. Uh, hardware. Let's suppose hardware. Hmm. This is all connected to a web server. Yes. So let's suppose this is the web server hardware, and now let's suppose now we have to make another web server for the AI agents to like browse internet and to purchase things according to the need of farmers. For example, this is the second API. This is not a very professional. Let's say this is the browser which is used for the AI agent to like purchase things web browser according to the need for the farmer. AI agent. Let's consider this internet. Internet. Yes. Let's suppose this internet. So this is the main models which are being looking like how it's gonna orchestrate and how it's gonna be needed in the future for the crop prediction feature. Like crop prediction feature architecture is being this. This is web server which is receiving the data coming from the IoT devices. IoT device server 2 is connected to the ML model for the pipeline for the analysis. And ML model it is being receiving the data, it is being sending the data to the JSON format and database dashboard, and it is also connected to web server 2 for the MCP server to like send data to the hardware and perform and MCP server to perform the hardware. This is all the hardware like pipes and irrigation system. based on the performing operation of the hardware and based on the computer. Database, caching, and all microservices, all the payments, all kind of things which bring for the personal data. So this is a general view of orchestrating AI agents and integrating a model for the crop prediction of farmers. And according to the orchestrating that web designing, including the hardware uses and the API uses and the machine electric appliances as well, and to perform and to produce a very reliable insight to increase the yielding and yielding of the crops. And also it is connected to the web server and the markets to and it has also a, for example, this is a ML model. Now create a second ML model for the crop prediction. This is the second model. This will be a second integrating models. Second model to analyze for the crop prediction, for the crop market prediction, like on the specific date on the coming date, which crop will be on the for the will be in the demand, which crop will be in the very demand in the next 10 to 15, next 3 to 4 months, and which gonna be get you more money, which gonna be will be best for the pesticide. It will also increase. It will also tell the farmers to which time to which the specific date proper planning. Like this is the orchestrating. It will also generate the proper planning for the farmers, like in which date it has to be pesticide, in which date it has to be horticulture, in which date they have to be irrigation, how much amount of irrigation, how much amount of pesticides to be integrated. This is the general model I want to talk. And it will also receive the